Okay, so today's lesson, we're actually going to cover NTI24 and 25. I took this last section and split it into two different math labs because it was a little longer, but I'm going to go ahead and put the notes all together. So starting with the first math lab, NTI24, we're going to be focusing on multiple angle formulas in this one. So we have double angle formulas and half angle formulas. Now, these, once again, are on that formula sheet that hopefully you've been able to download from document sharing. Okay, so we're going to start out in this first example. We're going to be looking at the double angle formulas. So we want to take the equation 2 cosine x plus sine 2x equals 0 and solve that in the interval 0 to 2 pi. Now, we did see in the trig equations section 5.3, we did see some problems that had a multiple angle, and we solved them without using these identities, but sometimes these identities may make it a little easier, so you see which method you like the best. Now, to start here, the first thing I'm noticing is that's my double angle. So I'm going to take that formula for sine of 2u and use that here. So that makes this equation 2 cosine x plus 2 sine x cosine x equals 0. Now that helps because now I can look at those two terms and I have a common factor. And so I can take out that GCF of 2 cosine x, and when I factor that out, I have 1 plus sine x. So now just set your factors equal to 0. And where on your unit circle is cosine equal to 0? Okay, and that would be at pi over 2 and at 3 pi over 2. And then where is sine equal to -1? Well, sine is equal to -1 at 3 pi over 2, but we already have that listed from our other factor, so we don't have to list it again. And so that's my answer. Okay, next example, we're using the double angle formulas again, but this time we know that the cosine of theta is equal to 5 over 13, and we know theta is between 2 pi and 3 pi over 2. Actually, I said that backwards, didn't I? It's between 3 pi over 2 and 2 pi. Okay. We want to find the sine of 2 theta first. So we know from our identities up here that the sine of 2 theta, we just use that formula, that's equal to 2 sine theta cosine theta. Well, we know our cosine theta from back here. So I can easily substitute that in as 5 over 13. Okay. Bring down the 2, but we don't know the sine theta. Okay. However, that's why this part is given. This tells me that theta is in quadrant 4. So I can draw a quadrant 4 angle. Remember, your triangle has to make a right angle with the x-axis, and you're going from the angle there at the origin. We know the cosine value is 5 over 13, so that's adjacent over hypotenuse. So what does that leave your opposite side to be? Yeah, that one's a triple again, so that's going to be 12. If it's not a triple, work out the Pythagorean theorem. However, we are in quadrant 4, so if I'm finding my sine value, I know sine's going to be negative, so don't forget your negative there. And then sine is opposite over hypotenuse. Now, if I multiply that out, my numerator is negative 60 times 2 would be negative 120, and then 13 times 13 is 169. Okay, then for B, we want to find the cosine of 2 theta. Now, if you'll notice on your formula sheet, you have what looks like a really long formula for cosine 2 theta, but it's actually 3 different formulas, okay? So there's one, here's the second one, and then this is the third one, okay? You decide which one you want to use. In this case, any of them will give you the same answer. If you're solving an equation, then it may make more sense to use one over the other because maybe you want it all in terms of one trig function. And so you wouldn't want to introduce cosine and sine, okay? Either way. Now, we've already found the sine value from the previous problem, okay? But if you had not found that, then this one would probably be the easiest one to use because you were given cosine, okay? We'll go ahead and use that just so you can see how it works. But once again, if you use a different formula, it shouldn't matter. You should have the same thing either way. Okay. So I will substitute in the cosine value, which was given to be 5 over 13. And so if I square 5 over 13, that's 25 over 169. And so that's going to be 50 over 169. And when you subtract 1 from that, you end up with negative 119 over 169. Okay, then for part C, it wants us to find the tangent of 2 theta. Now, my tangent formula is 2 tangent theta over 1 minus tangent squared theta. Okay. Now, we don't know our tangent value. However, I do have the triangle drawn up here. So if I look at this triangle, my tangent would be opposite over adjacent, so 12 over 5. And you're in quadrant 4, so is that going to be positive or negative? So I'm going to have 2 over, and what did we say, 12 over 5? So it would be negative 12 over 5. And then divide that by 1 minus negative 12 fifths squared. Okay, put all of that in your calculator. And you should end up with 120 over 119. Okay. Now, on this one, you also could have said that tangent of 2 theta would equal the sine of 2 theta over the cosine of 2 theta, because tangent sine over cosine. You already know the sine of 2 theta and the cosine of 2 theta from that previous problem. And so you could just divide negative 120 over 169 by negative 119 over 169, and you still end up with that same answer, okay? I wanted you to see how the tangent formula works, so I went ahead and worked it out that way. But keep in mind, if you're asked to find all 3, then you could do that. That would definitely be a little simpler. Okay, now switching over to those half angle formulas. I'm going to insert that again so we can have that handy. Maybe not. Okay. Okay, we want to find the exact value of the sine of 105 degrees. Must not have a good connection. It won't let me insert the picture. Okay, so we're using these half angle formulas. I'll just scroll back to them here this time. And so basically when we're finding the sine of 105, we're going to use this formula here, but I need to know that the sine of 105 is half of what angle? Okay, and that is going to be my u value. So when I write this out, I'm going to say that this is equal to the sine of 210 over 2. Because 210 divided by 2 would give me my 105. Okay. And so that's equal to plus or minus the square root of 1 minus the cosine of u. Well, now my u is defined as 210 because that's what I plugged in there to get my 105. So I put 210 here and then all over 2. Now the other part is this right here. Okay, I can't have two different answers, so I need to decide if it's positive or negative. Okay, well 105, that is in quadrant 2. So in quadrant 2 is sign positive or negative. Okay, so since it's positive, I'm going to come back here and just use the plus. Okay. All right, so now when I work this out, I have 1 minus the cosine of 210. Well, 210 degrees, that is in quadrant 3. Okay, and that's like your 30-degree angle in quadrant 3, so that cosine value, if you look on your circle or think about your angles, you're going to end up with radical 3 over 2. And this is actually minus a negative radical 3 over 2. And that's all over 2. Now that's going to equal the square root of 1 plus radical 3 over 2 divided by 2. Now this is pretty messy, so I'm going to go ahead and clean up what's underneath the radical here. If I'm dividing by 2, that's the same as multiplying by 1/2. Okay. So that's going to give me 1/2 plus radical 3 over 4 underneath the radical. So 1 times 1/2 and radical 3 over 2 times 1/2. Okay. So now I just need to get a common denominator of 4 here. Okay. And so 1/2 changes to 2 over 4. And then I leave my radical 3. Okay. And when you have the square root of a fraction, you take the square root of the top over the square root of the bottom, which is 2. And so that's your answer. Now it looks really messy because you have a radical under a radical, but one nice thing about these is you're going to be able to check them on your calculator, just like we did with those sum and difference problems the other day. So if you will pull out your calculator and I'm going to type in the sine of 105. Now 105 is in degrees, so double check your mode. Make sure your mode is in degree. Hit enter. There's your decimal. Okay. Now if I type in my answer, which was that crazy looking thing with all the radicals, I have 2 plus radical 3, and that's all over 2. I have the exact same decimal, so that's how I know I worked the problem correctly. So definitely use that to check. Okay. Now, these get a little messy. Well, not really a little messy, they get a lot messy. So try to be patient, and if you have questions, problems that you can't get, then shoot me a message, send me your question, and I'll help you work it out. Okay. Also, when you're finding the exact value of a radian, okay, or when your angle is in radians, that can be a little messy too. So if you'd rather convert it to degrees, you can. Okay, or just multiply your radian by 2 to figure out what your U should be. Now, that's the end of the first math lab on 5.5. Okay, so if you want to pause it here until you finish that one, that's fine. And then now we're going to do the product to sum math lab. All right, so hopefully, it's still not going to let me insert. All right, I'll just show you where they are. Okay, so your sum to product and product to sum formulas are here. Let me see if it'll let me put them in. Yeah, maybe. I think it just put them in second. Let's try that again. Maybe not. Okay. Well, regardless, you have them on your formula sheet. Okay, and so we're going to look at sum to product and product to sum formulas for this last part. All right, so this example says to rewrite cosine 5x sine 4x as a sum or difference. So we want to pay attention to this. Okay. And right now it's a product. So I'm going to go product to sum. So when I look at those formulas, I'm actually looking at this set here. And we have a cosine times the sine. So that's going to be the last one. Okay. So I will say that my 5x is going to be my u, and my 4x is going to be my v. Okay. So I'm going to write 1/2, and then my bracket, and then sine of 5x plus 4x, because it's u plus v, and then minus the sine of u minus v, so 5x minus 4x. Okay, and then just simplify from here. So this is going to be the sine of 9x, and this will be the sine of x. Okay, and then now we can distribute the 1/2. And that's my answer. Okay. You can't actually subtract those signs because one's the sine of 9x and the other's the sine of x. They both have to be the sine of the same coefficient of x. All right, next example says to find the exact value of the cosine of 195 degrees plus the cosine of 105 degrees. Okay, so we're looking here at this problem. Okay, and this is, we're adding two cosines. Okay, so let me see if it'll let me insert it yet. Nope. Okay, so we're going to go back to my photos here, and this time look over here at the sum to product, because that has us adding two cosines if you look at the third formula down. Okay, so I'm going to use the cosine u plus cosine v formula. And I know u is the 195 and v is the 105. So I have my 2 in front, so it's 2 cosine, and then the formula says u plus v over 2, so that's 195 plus 105 over 2. And then it says times the cosine of u minus v over 2, so 195 minus 105 all over 2. Okay, 195 plus 105 is 300. 300 divided by 2 will be 150. And then 195 divided by 105 is 90. 90 divided by 2 is 45. Now, since this one wants us to find the exact value, you're not quite finished at this point. You need to go ahead and evaluate the cosine of 150 and the cosine of 45. And you can do that because both of those angles are angles on the circle. So at 150, you want to know your x value. Okay, well that's going to be radical 3 over 2, and then it's negative because you are in quadrant 2, and cosine would be negative there. Then at 45 degrees, your x value is radical 2 over 2. That one's in quadrant 1, so it stays positive. When I multiply these out, my 2's cancel here, so I have negative radical 6 over 2. Now, these last two sets of formulas, the sum to product and product to sum, aren't really that complicated. The confusing part is to know how far to go. On this one, I kept going because it wanted me to find the exact value, and I could find the exact value because I have angles like 150 and 45. On that last problem, my problem had x's in it, so there's not anything you can evaluate there, and so that's how I knew to stop at that point. Okay. So good luck with that, and once again, if you have questions, just shoot me a message and I'll be happy to help. Hope y'all are doing great. I miss you all, and I'm really sad. I'm recording this the day after that we found out just last night that there's definitely no more school, so that makes me really sad. I felt like I was really getting to know you all well, and I hated that class ended like it did, but I'm sure we'll have another Google Meet or something before another quiz, and hopefully I'll get to see your faces again. So